civilization inevitably heading towards collapse because of our energy choices? It's a pretty heavy question, right?
And today we're going to dive deep into a really intense debate around something called the iron law of energy. We've got some really interesting sources lined up. There's Richard Lyon, an experienced oil and gas guy, also an electrical engineer. Then Joseph Tainter, an anthropologist and historian, who's basically spent his career studying why societies collapse.
Yeah, very, very influential work. And get this, an astrophysicist, Richard Gott, with his take on the Copernican principle. Kind of a wild card there.
Definitely brings a different angle. So our mission today, let's unpack these viewpoints. Are we doomed by physics, or is there, another way to look at this whole thing?
Okay, let's kick things off with Lyon. This iron law of energy, what's his core claim, the one that really sounds the alarm?
Well, Lyon argues that successful civilizations always move up the energy ladder towards more concentrated, more reliable power. His big contention is that the current push for clean energy, it's actually moved down that ladder. Unprecedented, he says, and potentially leading to collapse.
Down. That feels wrong somehow. We usually hear about progress up the ladder. So what physical constraints does he point to? Why down?
He highlights a few key things. First off, energy density. Basically, how much energy you can store in a given weight or volume. Fossil fuels, he says, are something like 40 times more energy dense per kilogram than the batteries we have now.
40 times. Okay, that's huge for things like storing energy or moving it around easily.
Exactly. Then there's power density. This is about how much land area you need to get a certain flow of energy. Clean tech like solar and wind generally has low power density. So you need vast areas of land to equal the output of one, say, compact fossil fuel plant.
Right, I see. So it's not just making the energy, it's the footprint, the sheer space involved. That's a massive infrastructure challenge in itself.
It really is. And maybe his most critical point is EROEI, pronounced EROI. That's energy return on energy invested.
Yes, EROI. It describes how much energy you get out for each unit you put in to get it.
Precisely. Fossil fuels historically were amazing, maybe 100 to 1 at their peak. Now, maybe closer to 20 to 1. But for wind, realistic system-wide values are around 7 to 1. And solar PV around 5 to 1.
Wow, so okay, put in 1 unit of energy, get 5 or 7 back. Yeah, compared to 20, that's a staggering difference in efficiency.
Lyon calls it a catastrophic fall in EROI. He argues that just building all this new low EROI infrastructure requires enormous amounts of energy up front. If he's right, then the trillions being spent are basically a disastrous misallocation of capital because the energy payback is so low.
And he has this bridge fuel point too, right?
Yeah, the bridge fuel problem. We often forget the huge energy cost of building the new system, especially when we're shutting down existing higher EROI sources prematurely. An analogy is pretty striking. Imagine shooting all your horses the moment the first car sputtered to life, before you even have roads or gas stations.
Okay, that really paints a picture, a pretty grim one. And it sounds like Joseph Tainter's work on societal collapse fits right in here.
It absolutely does. Tainter looks at history. He defines collapse as a rapid, significant loss of socio-political complexity. His main idea is that societies invest in complexity to solve problems, but eventually you hit a point of declining marginal returns, meaning it just gets more and more expensive energetically and otherwise, just to maintain the complex system you've built.
Exactly. It becomes increasingly costly, making the society fragile, vulnerable. He explicitly warns about vast disruptions and loss of life when industrial societies collapse. It echoes Lyon's points about energy being fundamental. So we have Lyon pointing at physics, Tainter at history, both suggesting some hard limits. But what about this statistical view you mentioned from Gott?
Right, this is where it gets really interesting. Richard Gott's take on the Copernican principle is a statistical argument. It basically says you're probably not observing something at its very beginning or its very end.
Like if you randomly check in on something, you'll likely catch it somewhere in the middle of its lifespan.
That's the idea. So applied to industrial civilization, which is only, a few centuries old, the principle suggests it's statistically likely to continue for a roughly similar amount of time into the future.
So Gott's statistics suggest continuation, while Lyon's physics suggests potential failure if we follow this clean energy path. How do those square up?
That's the million-dollar question, isn't it?
Yeah.
I mean, if Lyon is fundamentally correct, if the physics do prohibit this transition as he claims, then God's statistical argument, which assumes continuation is possible in the current form, might not apply directly.
Or at least the form might change. And Tainter himself notes complex societies are actually historical anomalies. Maybe civilization continues, but it finds a new equilibrium.
Yes, perhaps reverting to a lower complexity state, as Tainter might put it.
And we do see different paths globally.
Right, not everyone is moving at the same pace, or even in the same direction as Europe on clean energy.
Think about the US, China, and India all still heavily investing in fossil fuels.
That's a crucial observation. It suggests maybe Lyon's concerns and the potential for a Tainter-style complexity reduction could play out differently in different places. So maybe God's principle holds for civilization in some form, but Lyon's iron law could trigger localized or regional collapses, or significant realignments, as you called them earlier, not necessarily a single global event.
Okay, so putting this all together, what's the key takeaway for you listening right now?
Well, you're left with this really fascinating tension. On one hand, the physical, maybe non-negotiable constraints Lyon talks about, backed by historical patterns from Tainter. On the other hand, you have the statistical likelihood of continuation, at least for a while, suggested by God.
And that leaves us with a pretty provocative thought, doesn't it? If Lyon's physics are a hard barrier for certain paths or regions, then Gott's principle might still hold, but the resulting society after that realignment could look very, very different, probably simpler, poorer, and likely more conflict-prone.
It certainly raises profound challenges.
So the big question for you to think about is, can our ingenuity overcome these deep physical constraints Lyon points out, or are we facing an unavoidable, at least regional, societal shift?
How do you weigh the physics against the statistics? What does your gut tell you about our energy future?
Great questions.
That wraps it up for now. Thanks for joining us for this deep dive.
And do visit baffledbyscience.com to read a full review of Lyon's article.
And as always, we encourage you to keep exploring, keep questioning, and stay informed. Until next time.